In the last segment, we did a couple of problems using our graph and doing some math. And what I suggested you do was to turn the video off and try these two. So I hope you did that so you could check your work. How many grams of sodium nitrate would there be in an unsaturated sodium nitrate solution at 30 degrees Celsius? We need to read our chart. We see from there we can get about 96 grams per 100 grams of water maximum. So unsaturated is anything less than that per 100 grams of water. And then the last one, I'm telling you the information, you don't even have to read the chart. So when you see solubility, it's that number over 100 grams of water. This time now, we're not solving for the ionic compound, we're solving for water. So we have to solve for x in the denominator. So this times this equals this times this, which gives you that equality. We have to get rid of the 36, so we divide, we solve for x, and we get 222 grams of water. Okay, so now we're going to move into what's really particularly important with Unit 6, and that's concentration units. Okay? Now, when we were dealing with masses, we were able to translate them into something measurable via molar mass. Okay, so molar mass is grams per mole. Okay? And we got grams per mole by looking at the periodic table and adding up the numbers that we needed. Okay? For gases, molar volume at standard temperature and pressure, 22.4 liters per mole. As long as you are an ideal gas at standard temperature and pressure, you don't even have to look anything up. You just use that value. And then the mole will link you to the reactions via the reaction stoichiometry. So that was great. You had one thing that you had to do, and that was all you had to do. Well, how do we quantitate solutions? How do we take something like my coffee cup here, okay, my coffee cup here, which is dark, and I know you can't see it, but I could ask myself, well, you can't see much there, but I could ask myself, what is the concentration of caffeine? What is the concentration of protein if I put milk in there? What is the concentration of sugar if I put sugar in there? What is the concentration? So when we have some kind of substance dissolved in water, we need to use concentration units, and it makes our life a little bit more challenging. Okay? And the reason for that is there are many different units that depend on the nature of what you're looking at. We have percent mass by mass, percent mass by volume, percent volume by volume, molarity, molality, normality, and we could even put equivalence on here. Okay? So that's really a drag, because what we did before was we only had to know one thing to get from a solid, okay, imagine a solid in my hand, to the reactions. For gases, we only need to know that, and then we can go to the reactions. For something dissolved in water, this is a nightmare, okay? Now, there's good news and bad news depending on your point of view, so let's be optimistic about this. We want to think about this from a positive standpoint. The bad news is there's a bunch. The good news is that equivalence, normality, and molality will not be covered in this course. So the good news is out of this list, we're only doing 1, 2, 3, 4. So it's not so bad. Okay? So we're going to start with percents, because most of you are taking this course because you eventually want to go into allied health programs. And even though molarity is the standard unit in chemistry, we want to address the needs of our audience. So percents. Okay, so percent mass by mass is a unit that you would use if your solute is measured in grams and your solution is measured in grams. Now, the biggest problem that people have here is that solution is the solute plus the solvent. Okay? Solvent is typically water. Solution is something different. Okay? Water is not a solution generally. Okay? Unless you get into a discussion about tap water having ions. But go with my analogy here. Okay? So is my coffee, okay, so here's my coffee cup. Is my coffee the same as water? Clearly the answer is no, right? If I want water, I drink water. If I want coffee, I drink coffee. Okay? They're not the same. The coffee is made with water, but they are absolutely not the same. Mountain Dew. Okay, if you're not a coffee drinker, maybe you drink Mountain Dew. Is that the same as water? Is Kool-Aid the same as water? Is beer the same as water? Is rum the same as water? They're not. Okay? So the biggest problem that students have is they think water is the same as the solution. So please remember, water is not the solution. Water, in our application, is the solvent. Okay? So that's where you're going to have your biggest source of error. Okay. So what is the percent mass or mass percent of 40 grams of barium chloride dissolved in 125 grams of water? Okay. So the water is part of the solution. So the percent mass by mass is the solute, which is 40.0 grams, divided by the mass of solution, which are these two put together. 40.0 plus 125 times 100%. Okay, so you're going to push some buttons on your calculator. You're going to round to three significant figures, and you should find that that's 24.2% mass by mass. Okay? Because your numerator is a gram, your denominator is a gram. Okay? Now, what if I change the wording and instead of water, I say solution? Then the percent mass by mass is 40.0 grams of the barium chloride divided by 125 grams times 100%, which is equal to 32.0% mass by mass. Okay? These are very different. These are very, very different. If I took the percent difference between that number and that number, okay, 32 for easy math minus 24 divided by 32, okay, so I'm rounding, is 8 divided by 32, which is 1 over 4, which is 25%. Okay, so if you have this value and you're supposed to have that value, you are 25% wrong, or vice versa. 25% error if you're dealing with, say, a patient or a dose or something like that is enough to probably kill somebody. Okay, so you have to make sure that you're understanding the terms that you're using. Okay, the last one, again, is water. So mass by mass, this is grams, that is grams. 25.9 grams divided by 25.9 plus 178.3 times 100%. Push some buttons on your calculator. 12.7% mass by mass. Okay, so this is all great and well and good and all, but it's sort of rhetorical. Why would you express water in grams and not volume? Well, it's rhetorical because most people most of the time don't weigh water, you pour it out, right? You pour yourself coffee, you pour yourself some water, you pour yourself some Kool-Aid, you pour yourself some Mountain Dew, you don't weigh it. So the next unit, we'll take that into account.